All right, picking up on page 52 here. So we talked about instances where we are looking for areas or probabilities associated with z-scores. Among other things, we're going to talk about how you go the other way if you're given particular areas. But I want to address a contextual situation first. All right, so example one, distribution of weights of black bears is assumed to be normally distributed. Well, assumed to be normal, because I already covered the distribution part. With a mean of 183 pounds and a standard deviation of 121.8 pounds, find the probability that a black bear selected at random will have a weight between 150 and 180. So what I'd want to do is find the z-score for 150, then the z-score for 180. All right. Now they're telling us that the mu is 121.8, and the sigma, actually, sorry, I apologize, that is the sigma. The mu is the 183. The sigma is the 121.8. All right. Now, what we're going to do is find the z-score for each one of these particular values. All right. So z is equal to, x minus mu over sigma. All right. So what I'll do here is, using that formula, these are our x values. All right. So 150 minus 183 over 121.8, and then 180 minus 183 over 121.8. All right. So these are both x values. All right. So essentially what they're asking for, let me just smidge this down real quick. What they're asking us for is the probability that any randomly selected x value would be between 150 and 180. All right, so what we're going to do is figure out the corresponding z-scores and use our norm CDF function. All right, so 150 minus 183, close it up, divide 121.8. So that's one of the calculations. The other, 180 instead of 150. And so we get z-scores between negative 0.271 and the other z-score negative 0.0246. All right, so in effect, what we're looking for is the probability that z is between these two numbers. All right, so on my diagram here, negative a quarter-ish, negative 0.27, so somewhere in this neighborhood. If we assume this is negative 1, then negative 0.27 might be right here. 271. And then just a smidge to the left of that vertical axis, we have the 0.0246. So it's going to be kind of hard to see it, but it's going to be like in this neighborhood. All right, so 0.0246. Here's a thinner. Not much better, but slightly. All right, so we're looking for this little sliver of area. And that would give me my probability. So to do that, we're going to do norm CDF range. So toolbox, normal, so probability distributions, normal, and then norm CDF range. So negative 0.271 on the low end, negative 0.0246 on the high end, 0 and 1. All right, so if I hit OK on that, it should give me a fairly small probability. Yeah, about close to 10%. So negative 0.09, it would go 0.970. All right, so this one is going the other way. So example 2, using the information in example 1, so the mean standard deviation, find the weight separating the top 25% from the bottom 75%. So that's the same as saying the 75th percentile, which we already computed up here. So we could do it all over again. You know, just kind of estimate where we think 75% of the data would be. Right, find the z-score corresponding with that. But then the additional component, so we could basically do all this work again just to come up with the fact that that's going to be 0.674. So, instead of reinventing the wheel, I'll just say, well, we know that that's 0.674. What I now want to do is find the x value corresponding with that. So again, the mu is 183 and the sigma is 121.8. Z is equal to x minus mu divided by sigma. So 0.674 is equal to my unknown x minus 183 over 121.8. So then we would just solve for x here. Cross multiply. You can put this over a 1 if you want. X minus 183 is going to be the product of these two numbers. So 0.674 times 121.8. So we're looking at about 82 and change. I'll write the whole decimal here. Then add x to both sides. I'm sorry, I suppose there's a universe where you could do that. But I meant to say add 183 to both sides. So plus 183, 265.0932. All right, and this is in pounds.